Hello, everybody. Sorry we're a little late. Um, a lot of people were in a mad rush to get this going, and maybe it's just too early for us on the northern Americas. But we're here nonetheless, and see who we got. Uh, Jeremy, Ryan, Terry, and McCope. So started off, I guess we want to talk about the SEC challenge, just to encourage wireless transmission of power. Jeremy, you're the
You want me
man
to
for
go
that.
through any? You want me to go through a little rundown of that, or?
Go for it.
All right. All we're this is me mixing up this little ABS slurry here. I'm just gonna talk while I'm doing this. All we're looking for is a basic transmission from a source tower to a receiver tower. Completely wireless, no wires connecting. Um, the only connection can be ground between the two, and the ability to light up a fluorescent bulb at the far end. Outside of that, the sky is completely the limit. Um, as long as we don't have any wires connecting the two or anything conductive, a big nylon net dipped in water or something on your roof or whatever, um, then it's all pretty straightforward. I mean, I don't know how else to say it.
I think it's a pretty good idea, and we'll encourage people to experiment more with that. More,
Well, yeah, and to share the knowledge, to share it, right? Like to get some kind of a standard, because there's really no standard for dimensions, circuits, anything like that. It's all over the place.
yeah, the only thing that I've seen or read really is just surface area and then measuring capacitance in centimeters and coming up with your
Yeah,
measurement and a lot of RF, radio transmission information. Yeah, you're right. There's not a whole lot. Seems like the people who do it kind of do it secretly, very secretive.
yeah. Well, and this maybe there's no one's given a forum to talk about it on, or they're afraid of being ridiculed by people because they don't understand it, or whatever it is, right?
Yeah.
But I don't understand it. I don't get it.
Well, it's like shit. Well, the SEC stands for either Slayer Exciter Circuit or spatial energy coherence, right? So depends on.
Yeah, I'd like to hear you talk about the spatial energy coherence a little bit more because that's obviously a little more applicable.
Well, Dr. Stifler is kind of where I got where I first heard that term, the SEC, and I always thought it was a Slayer Exciter Circuit, but
Yeah, same.
with Bluer, but they're all very similar circuits in that they're like basically transistor-driven mini Tesla coils, essentially. Like you just have a, a buildup of a field and a collapse of a field, and it emits a radiation. And
Yep.
people radiation not being the bad alpha radiation that familiar with that.
How about it radiates energy? Does it?
Yeah, it radiates energy. Well, that's all radiation is, just an emittance of energy uh,
Yeah.
through space. So spatial energy cohesion is just basically how that energy moves through space and playing with circuits that we have shared capacitance in a spatial field. So that's pretty much it. And some of the things that I encourage people to go check those out if they haven't seen them is the Dr. Stifler's SEC 18 is a good one. And there's a couple of good ones, but Lid Motor's done a couple of little demos of it, and I've set up some
Yep.
demos, but still haven't been able to get it going very well. And kind of hit it here and there, but one in particular where you can actually make a diode. It's just a fast switching diode, produce hydrogen and I believe oxygen too. Of course, produce electrolysis just off of this diode, and the diode's
Yeah.
not connected to anything. It's just in. the water with a coil around the outside.
I really want to try to duplicate that.
Yeah,
I'd really like to see that. Yeah.
pretty cool. And Lid Motor duplicated that one and got results, but it wasn't as impressive as Dr. Stifler had
Right.
shown. But I almost think that that Gary too is probably has some stuff he's played with and been playing with and just doesn't show. He seems like a pretty quiet guy. So, he doesn't talk very much. He just does a lot of listening. So. Interesting to see some.
Maybe that's the key. Maybe that's the key to understanding.
Yeah, Gary's probably running his whole house off of 3 volts or something.
I think you got a point there too, Gary. It probably is a good point of understanding, just to be quiet and listen.
Yeah, I was looking at one of his circuits this morning that uses 3 2N 222s, and its maximum voltage intake is what did he say? 3 volts. And I remember I did that circuit months and months and months back during the winter, and it was one of my first videos with any kind of wireless power. I just remember it lit up quite a few bulbs, and it was only running 3 volts off of just a couple, 3 no 2 double A's, yeah.
Yeah.
But it's I'm sure if he came up with this, this diagram or whatever's dated 7-2-10. So I'd say he's probably come up with something.
Yeah.
Well, I know he's still active because Mr. Bluer just added me about 2 weeks ago on Google Plus, so he's doing something.
Yeah, he's active, but I think he's just a listener. He just sits and listens and learns. He probably learns a lot more about others.
He gets 3 or 4 videos a day about Slayers.
Oh yeah.
One of us did.
Yeah, seriously, one of us will one day. It's.
Well, the SEC primary function, or it's based around the L3 in a sense, like the way that he has it set up. It's really the L3 is crucial into kind of oscillating between 2 field presences.
Yeah.
Weird.
Yeah. Yeah.
Cool though. Very cool stuff. That's very fine tuned though. And a lot of the circuit diagrams and stuff.
That's what I was hoping to explore something so that you can get the results without having to make it so touchy. If I could transmit to another tower and be able to walk all around it and still not disrupt the field. How do you, just ways to explore how to lock it to that pickup coil a little bit better than just having the pickup coil pick up some of the source, right?
It could be that conducting through the ground or through the ionosphere, or doing both at the same time and having like a pinpoint capacitance through like vectoring or something. I don't know. It's interesting.
Yeah.
It could be more involved on the matter itself, the material, like having an antenna or having a deep ground or both.
What I was saying, me and Abrams were talking the other day, and I was saying that it's kind of confusing because we might not have the right terms to explain what we're looking for yet, right? We might not have the language. We might not understand the principles to know exactly what it is we're looking for. So, it could be that we're just exploring a new variable, right?
Yeah, exactly. And that's very much true. I agree with you guys.
Well, I've set up maybe 4 or 5 different ones this morning, and it's all different. It's just kind of driving me crazy, to be honest. And that's just
and you've done probably more of it.
It's because I'm working on that weird circuit I was telling Dighton. I'll try to put this up at the camera and people can see what's going on with this. But this is a 2N 222 It's a what is it? A 440? Yeah, I think it's a 40. The resistor, and then I just have a diode in here coming off the or going into the emitter, or coming off the emitter. So that would mean your negative's connected to the diode. Anyway, so the bottom of these two are positive and negative. Then I put a little wire here, run going into my L1. L2 connects to, or the coming out L1 connects to this pin, which would be your collector, I believe. Yeah. And then, yeah, your base run to your L2. So basically, it's a one diode. Well, not, I mean, kind of, right? LED's a diode. So, but it's using a LED, and it runs off of a 9 volt. Anything higher than that, it'll just oscillate it and make it pulse like a strobe light. So, but it puts no plasma out of it, or nothing out of the top, no sparks, nothing. And the LED actually fluctuates. Well, like you guys were just talking about, when you get near the field, the LED will get brighter or dim down. You can find the sweet spot on the coil real quick too. Rubbing your finger up and down, and it'll wherever where it's the brightest, usually is kind of where you should put that primary. So.
Well,
Hey,
that's
Abrams.
plucking a string, or the string can move up and down and left to right.
Yeah, go ahead.
And,
What, Nico?
you know my Tesla coil, right? You know how it looks? Yeah. I'm interested in the results if I made it into a giant exciter. I mean, just the way it is with the bigger primary.
Yeah, that's like Terry's been talking about doing that, right, Terry? Well, you're talking about making it solid state. You just the solid state using.
Yeah, but I'm interested in if the principles with the tuning would be the same.
Yeah, to a point. If you made a Slayer, how can I? Yeah, you've sent me transistors. Like there are transistors that can handle that. That copper. You got depending on how thick the primary is. I mean, I've run Slayer circuits on the Tesla coils. And it does work. The transistor gets kind of hot. I mean, just because I think it's just the primary, just how thick gauge wire that is in comparison to a normal Slayer.
The primary up and down, I've eliminated much of the windings, and that's where it's tuned properly for Big Red there with that big giant top load. 6 inch.
So you found this.
Another
Mark got Tesla coil when they disconnected. Sorry. Check this out.
Here you go, Miko.
Yeah. Can you guys hear me?
Computer was too close to it.
Oh man, gosh, every time, man. He tries to show me stuff, and it's just like, all right, we're back. No, there he is. Back. No. Yeah.
I'm wondering if you consider that a bad result or a good result.
What? The camera going off?
Yeah, I got
Consider
this.
that. I don't know. I have been able to. It's very violent frequency probably.
you joined and then left again.
Did you do it again?
Yeah.
It's like the thing I hooked up last night. This weird, funny little. And for most people, nobody even got to see. Like Terry's just shaking his head. The aluminum foil spark gap coil.
I love that.
I don't even know. It's just so weird that he even did anything. So.
Were you able to measure any resistance on your graphite side?
It didn't get. I don't know. I mean, I set it sideways. It was, maybe 5 inches up above it or something, and then it just didn't work. It was really weird.
What is it?
The fact that there's so many spark gaps going on. it would
Forget it.
it was a failure to start with. I was going to use it for I wanted to use it as a
Oh wow.
primary for the Slayer. Anyway, you there, Terry?
Did the Slayer
I think, yeah,
kill
here's
your
one.
video?
Terry needs to build a cage to put his stuff. It took 4 times to record the video with this thing yesterday because it was just so, it's just throwing out just weird.
What the hell's going on?
Yeah.
All right, Mika, can you see Terry?
Yeah, I can see him.
He'll show you, I think, what question.
If it doesn't go off.
Yeah.
There it is.
Oh, that's awesome.
And that's running off what, Terry? And don't say a potato.
Yeah. I would estimate you running at about 10 volts. Maybe 12.
Yeah, I don't know. It's been running these things, some of them. I don't know yeah.
Yeah, it works just fine. Yep, he went again.
Y'all saw that. I saw the lights get really bright, and then all of a sudden it cut out.
Did he turn it up?
Yeah.
He tuned it, yeah.
I wonder what he's using. What transistor he's using.
Do you consider that?
Slow motion for a minute.
Do you consider that a bad result or a good result?
I think if it shuts down something, it's a result. That's for sure.
Yep, everyone was in slow motion, including voices.
interacting conductors and electronics, trying to excite it. Yeah, Jeremy, his long tower is interesting in that, like, if you move the bulb up and down, you can see almost like
You can
nodes.
see the waves of electricity.
Yeah, exactly. Nodes,
Right.
just like sound, just like sound waves.
It's hard to pick it up on camera.
Yeah.
Yeah, but you can do it with spark gap test request too.
Yeah.
If the frequency is low enough.
Gary needs to turn Chrome on.
See if you can go to what's something simple but cool that he could print. Jeremy.
Maybe a pair of dice.
Paradise. Interconnecting that. Huh? You can do something complicated, like little puzzle pieces. Gosh, I'll show you what happened to me. I just took this apart, or I just dumped the oil out of this, and look. I'm gonna have to get thicker glass or something, because
You said you blew a hole through him.
Yeah, when I investigated the first time around, but after I reconditioned this, I was just trying to take that bottle out, and the whole freaking lid fell off.
Wow. Yeah.
Cut through it.
The oil in the water line needs to be the same in the bottles and around the bottles.
Yeah, the water line was the same, and the oil line was above the bottles because it kept arcing through the oil without it. It's a 50 here. This is my new power supply. This is why I'm having problems, because it's a 15 kV NST.
All right.
big brick of an NST. So
Time to get some thick wine bottles.
yeah, that's exactly. I gotta get some. Well, I got some of these Coke bottles. I'm gonna try that. It's pretty thick.
I think beer bottles are the best. I don't know.
The brown beer bottles have special RF properties.
I didn't
They're
hear
glass.
anything. You're breaking up.
Yeah.
That what,
Sorry,
Terry?
I'm on mobile.
Yeah.
The brown beer bottles have
Yeah.
better RF qualities than clear glass.
Because they're semiconductive.
No.
What's the pigment that they use for the brown?
I
They have
think it's iron or something. I don't know. I'm not sure.
Do they use a pigment or anything, or
Yeah, I'm sure they use a
it's a
pigment.
certain mineral.
yeah?
It's a form of crystal, I think.
I can research it right now.
Yeah, that'd be awesome. That's interesting. Yeah,
Tesla himself found a special champagne bottle that he preferred over anything else.
really.
Yeah, he said it had special properties and enhanced capacitance or something.
I wonder if it was made out of crystal, like quartz instead of glass, instead of silicate. Well, I guess they're all silicate varieties, but
You're talking about crystallized silicate.
yeah,
Yeah.
yeah, just where it's more the lattice work. I could be wrong. I think silicate has like a hexagonal type of lattice work. I think it might be rhombal. I'd have to research it, but just the different types of lattice work seem to improve like dielectric strength and just like that buildup, that transition between the two conductors, that kind of interaction. So like mica and quartz, they're all different. They all have different properties.
Yeah.
I'd like to get some nice heavy duty mica capacitors. Well, that's another thing I want to get your guys' opinion on is like I was doing I went back and reviewed that Dollar. I noticed that he has a Tesla coil on the up front. My first question would be, what do you think? Do you think that it's just a straight induction coil? He says it's a medical Tesla coil, but do you think it's an induction coil, like a bipolar, or do you think it's an actual frequency resonating coil? Like a quarter wave frequency resonating coil.
The old medical type were just induction.
That's what I thought.
They didn't use resonance, and they had metal cores too, didn't they? Soft iron cores in a lot of cases.
So it's basically just an NST, in a sense, only is really high voltage, right? More like a flat
Yeah, and would use a battery, a low voltage, high amperage on the front end in the form of a battery. And a mechanical oscillator of all different types.
So usually it would be like a relay setup, stuff like that.
Yeah. Or like those little bouncing rods that you can adjust the spring tension.
Yeah,
It keeps bouncing.
And then you could change the frequency of the upfront with that, huh?
Right, which decreases the voltage as you increase the frequency.
Right. That'd be fine.
A tunable power source.
Yeah, exactly.
That's what it sounds like to me.
Yeah,
So that was the first one.
yeah, basically what it is. So, and then my other question would be, what do you guys think about this? The after it goes in, it stepped up to the extremely high voltage, then it goes through a spark gap, right? That's basically going into that's going across in parallel to a capacitor, a large capacitor. That's when I say large, I don't mean necessarily in capacitance, but just its dielectric strength, because it's like a 1 nanofarad capacitor. It goes into his pancake coil, right, or it goes into the primary in parallel, and with a spark gap across like a hairpin, and then goes into his pancake, and then but he adjusts the spark gap, and then he's coming up with like he can walk a whole football field length and still pick up the same off of another coil with the same capacitance and the same number of turns. You think that that it's if you have a high potential on the upfront before the spark gap, you think that it would increase like electrostatic type of, you know what I mean? Bring it closer.
Yeah, I'm at on my setup with the phone. The capacitor string is a really low nanofarad but high voltage 40 kV, and it's nanofarad 40 kV because I have so many in series. So it takes capacitance down, but the voltage dielectric strength up, and the spark gap fires through the pancake and right back into the earth ground, and the negative high voltage terminal of the flyback is connected to the earth ground too. So, and then the bottom of the Tesla coil on top of the pancake, the first wind is connected to the earth too, which is really strange.
Yeah.
It's kind of like what I've done before, but this one works great. It's better. It's strange because of that tall tower and the small pickup tower are not even close to being the same number of turns or size of wire or anything. They're totally different. You know, one's 3.5 or 4 inches, and the other one's 2 inches. It's
Lost them.
it shouldn't even resonate with each other.
Hit the mute button. You there, Terry?
Yeah, I'm here.
Hit the mute button.
Nope.
No, I just lost it a little bit. You still have that set up? You should show that again now that we're live.
Okay.
It's interesting. It's almost like a feedback from the ground itself. Seems like.
So this coil, it's not connected to the circuit. It's the Slayer exciter. It's not even earth ground. I've got a 2N3055. And basically, this is the pickup coil. And this is a trifilar. So it goes in at the top, comes out, goes back in, comes out, back in again and comes out, and then goes out to the flyback primary here. So when this one's connected, there, it's a trifilar.
Yeah. So it's coming out in the same radial spin as it went in, basically.
Yep.
Instead of reversing altogether.
Those first 2 pins, that's all I'm connecting to, except for the low voltage or the negative high voltage. It goes out to earth. And the capacitor string is here. Goes down.
Oh, I see. And what are those rated at? What are those rated at? I'm losing audio, probably just on my side. Last time this happened, I couldn't hear anybody, but I was still
Can you
there.
hear me?
Yeah, I can hear you.
Hmm.
Good. Terry's just dropping off a little bit then.
But we can still see the video. That's
Yeah,
strange.
that's good. He said it was 45, 40 or 45 kilovolt string. I wonder what they're trying to show up close of it.
I think those are around 2 kV a piece, but I'm
Here
not
we
sure.
go.
Yeah, 4 kV a piece.
Okay, yeah. At
Hmm.
0.106 nano, or I can't tell.
I don't know.
Probably rated in picofarad in some way. They look like polyester style,
Yeah.
little polyester style caps. So stepping it up into the spark gap. He's got three. He said he had three connections, I think, from the to the ground.
Yeah, yeah. Yeah.
From the pancake coil.
Hmm.
There. Yeah.
But I'm wondering why
Wow.
isn't he talking?
What's that?
I'm wondering why isn't he talking? It will
Uh,
be quite easier.
Audio probably fell out. He's on a mobile phone, so
Yeah. I can see he's muting and unmuting it all the time.
yeah, it's just the connection's bad, I think. Hmm. Yeah, audio's out. Oh, okay. It's
What
connect.
happened? Yeah.
I don't know. His connection's bad. You
Yeah.
gotta learn some sign language.
Yeah.
Or
Yeah, he was out.
have
Yeah.
some, some charades. It'd be tech tech charades or circuit charades.
Testing one, two, three.
There we go. Oh, we got you.
Hey.
Okay. Yeah, those were 6.8 nanofarad each. Let's see. Um, the flyback charges all those and fires through the carbon rod spark gap that I made out of the D batteries.
Yeah,
Now those are the double A battery carbon rods,
those are pretty small.
and that's about 2 millimeters on the spark gap there. And I guess you'd hear it earlier
Yeah.
and see the. I don't know.
Are those caps smoothing out the frequency at all? Because I hear the spark gaps frequency. It doesn't look the same as the plasma coming, the arcs coming from the top. Maybe it's just the camera rate.
Yeah. The the spark looks way smoother.
Yeah, way faster,
Yeah.
faster rate of fire than the actual spark gap from the flyback, which I think is what we're hearing.
Or just yeah. That's interesting.
Oh, now I see. That's interesting. When he moves his capacitance, his body
Oops.
body ground in, yeah, it changes the frequency altogether. That's why.
Or
Yeah.
maybe he's just grounding in the energy.
No, if you get in the field, it affects the. Yeah, I'm on the other side now.
Huh.
I think you're just sucking all the energy to the ground.
Right, I'm taking it away from the circuit so it doesn't transfer to this tower
Which
over to this flyback
right.
through the pancake here on the bottom. That's the only place the flyback is connected is to the pancake.
Oh, okay. What's the what and what are you driving it with?
The voltage is at 36 DC
Okay.
at point zero. It's 0.2, so 200 milliamps.
Okay. 200 milliamps, 36 volts.
Nothing gets hot. The transistor don't get hot at all.
That's awesome.
Did you get to see the plasma earlier? I don't know. Off
Yeah,
of the
we
top,
saw it. Yeah.
Good a bit.
it'll make my camera cut off.
Yeah.
It's like a flyback
Yeah.
by itself. Anyway,
I see. That's very cool, man.
it's different for sure.
Hmm.
What?
It's definitely spatial energy coherence.
Yeah. And it seems relatively efficient. I mean, if you're running if you're running the flyback at I don't know, you know you'd have to find out your output of the flyback, I guess, and stuff too. But you're running your flyback.
It's deadly. It'll shock you so bad over there on that end.
Yeah, I bet. It seems like iron does that because it builds up a larger capacitance, you know, like a large in its own magnetic field, like in the iron itself builds up.
If
It's like
you
a
add
capacitor.
more capacitors, it'll take them longer to charge. But when they do discharge, it sounds like a 22 rifle went off.
Yeah, when they're all in parallel.
Yeah, yeah.
Yeah, I bet, dude.
And you can get a really slow pulsing Tesla coil that shoots a 6 or 8 inch arc every couple of seconds.
Builds up and builds up.
It's fun.
Yeah, that's pretty cool. Well, man,
I can do all the same with 12 volts. It works basically the same, just not as powerful.
yeah,
It still does all the same stuff, even the distance is the same and all.
200 milliamps still, or does it draw more amps?
The amps goes up when you lower the voltage. That's how I destroyed one of my meters. Again.
Yeah, I've lost 2 of them so far. I just haven't had the money to buy another one. Ryan is taking care of it, so he's probably in and out.
Huh?
What?
What?
Man,
I'm blowing things up, man. Yeah. Mm-mm-mm-mm.
Jeremy's gonna print something.
What's he printing?
I don't know. He asked for suggestions.
Nobody came up with anything yet.
Yeah. Well, no, I think Mikko said a T. Print a T.
Print a tube that's got candy cane grooves in it.
Yeah, that's a good idea. Or go look up what is it? Tesla one-way valve using boundary layer. I don't even remember what those are called, but I saw that they have them.
With no moving parts.
Yeah, it has no moving parts. It's just a one-way valve that uses pressure flow, boundary layer, and just yeah, those pretty interesting.
Bring a potato.
There you go. He's back.
A big plastic potato. That'd be hilarious. Make a slot in it so we can put stuff inside.
You guys have to see the wireless potato.
Oh, Lord.
Let's see. Like a Tesla air diode.
Alright, let's see, we have a potato.
Here we go.
Potato. He is going to do it.
That's a mysterious potato there. It was wireless.
Here's a crazy potato.
So, does anyone know how can I burn the diodes inside a flyback without burning the actual flyback?
Mm-hmm.
Over voltage maybe. Push too much through.
Yeah.
Backwards.
Backwards. Yeah, actually,
Yeah.
it's probably even simpler answer. Back spike, some crazy back spike. Just
It's a pretty robust flyback. Since it survived so much time running a Tesla coil.
yeah. What did you put it on?
The potato.
That's it. It was a potato.
Blow it. Blow it.
Is that from your Tesla coil that you blew your flyback?
I'm sure this potato is from Chernobyl.
Chernobyl.
Yeah. I'm 100% sure now.
There you go. That's why.
That's a good wireless field. It's strange. I've never gotten much wireless just off the flyback. But when you put a potato on it,
Oh, God. Potato top load.
Yeah, exactly. I don't know.
The scientific explanation is
Layer.
Just put a potato on it. It's probably because of the larger surface area.
Yeah. And it's conductive, more conductive than the air.
Yep.
Or maybe it's just because potatoes have special abilities.
Yeah. Superpowers.
This magic potato.
Magic. You can't understand something, it must be magic. That's
Yeah.
Exactly.
That's how it's always been. That's how it always will be. A volvular conduit. That's another name for it. That's the valve. I'm trying to find a 3D print of it. The it would be super cool if we could develop this further as far as wireless to where I don't know, we might get in trouble with some type of FCC regulations or something, so we'd have to like transmit it through the ground or whatever. Probably be the only way you'd be able to do it in the first place. But two potato action. But it'd be incredible if we could set up a free wireless power net. Wouldn't that be cool? You just people have access and just transmit it to other people.
Joe Jacobs.
Yeah.
The potato Jacob's ladder.
You should patent it.
Yeah. Right. Make some high voltage French fries.
Ozone flavor.
Yeah, ozone flavor.
Pretty much.
That actually smells like French fries.
Does it really? Because it's burning a little bit. That's this spark gap. Oh yeah, that was another question I have. With your carbon rods, have you ever noticed a white spark gap?
Yeah, it's really bright blue and it bounces all over the place, self-quenching for some reason. It's really strange. It never sparks. It sparks in alternate places every time it lets loose. It sparks in a different location.
Yeah, it's really
That's
cool.
probably because small pieces of carbon are exploding when the high voltage hits.
That's exactly what's happening.
Right, but they're so small. It doesn't corrode. I thought it would corrode a lot faster, and it actually doesn't corrode that fast at all.
Yeah.
It's actually
It stays.
because basically what you're doing is just making, more carbon in a way. Like you're destroying carbon at the same time. That's what
It
happens.
probably turns it into nanocarbon on the tips.
Yeah, exactly. It makes it smaller and smaller in a sense. You're breaking it apart. We're collapsing it. What was that?
I went up to Canada and stole Benja's motor. No, anyway.
Ever notice white, Terry, in between those? Has it ever turned white on you? Like flashes
If you,
of brilliant white.
Good.
Yeah, it becomes an arc lamp if you get them really close together, and you're constantly ionizing the gas between them to where it doesn't really break the gap. It becomes an arc lamp, which is so bright it looks like you're welding.
Yeah, that's exactly what it looked like for me. But it only happened when I did a hairpin, and yeah, it just turns white like but it was a pretty wide gap, so I'm surprised. I wonder if just a frequency has something to do with that. The frequency is so
The temperature rose to the point where it could sustain that arc.
yeah. Yeah, because you're completely ionizing the gases in between, so you make almost like the air becomes like your mercury, right?
Yeah, the arc lamp at that point. Which I did do that experiment with 120 volts just to see, and it's so bright it could light up your whole backyard. If you had a reflector and a lamp to put it in, I'm sure it uses probably 1,000 watts.
This is just on a tiny scale. It looked like a little star, just crazy, man. And it happened when I did the last experiment I was doing with the diode from ground into the system. And every time I put the diode from ground into the system, it started to flicker and started to, like I'm getting some type of heavy feedback from ground or something. It was weird. I'm gonna do it more once I get this running, but I have a bigger power supply now, so I have to I'll have to start over completely on those experiments just where I do everything right. And hopefully the diode that I pull from a microwave will be able to handle this a little more. Probably not. I'll probably have to grab another diode.
Yeah, those are
Can
good
you
for
find?
10,000. So
Yeah, and I was using a 9,000 volt NST.
man, that
Now I have a
thing it
15. I don't
needs
think.
10,000 DC.
Can you find old TV? I mean, from really old, from the 50s. They have some 20,000 volts diodes in them.
Yeah. What like
Most
you
of them
talking about?
have a voltage multiplier.
Like a Krakow Walton style?
Yeah, and
What type of what type of
you
voltage
can get the
multiplier?
diodes from them.
Oh, okay. Yeah, I don't know where I'm gonna find a 1950s TV. I've got a few tube TVs, but
That
the
stuff's
Interesting.
vintage. They're paying for that.
yeah,
People are nowadays. We got two giant carbon rods right here.
no.
I don't know. I gotta find a better way to do this. I gotta move the camera. This is kind of pointless at the moment. That'll work. Maybe.
Yeah, it'd be cool to set up a discharge tubes too. I was looking online. Hard to find any
What?
any
Fine work?
discharge tubes, like higher
Oh.
rated discharge tubes. You can get little tiny ones off of a TV too, like a little it look like almost like a diode, a little clear looking. I don't know. Like, if you took a fuse and just broke the filament in it, maybe you could make it discharge tube out of that. Right?
Pop the film. Yeah.
I don't know. I don't know if that would work, but gotta find what's looking into vacuum tubes and stuff, and there really was like a monopoly on vacuum tubes. The people who made vacuum tubes, like, it was just a handful of companies, and that's it. And so once they all decided not to make vacuum tubes anymore, it's hard to find vacuum tubes. I mean, little mom and pop vacuum tube place. Expensive. So what have you been working on, Miko? Anything? Going to school?
Oh, no, nothing.
Much?
I've been thinking a lot for a lot of things, but nothing in particular.
My kids got this glow in the dark bubbles for their birthdays. It reminded me of you. Thinking about the glow in the dark paint and stuff that you were talking about.
Yeah. Are those the discharge tubes you're talking about?
I can't tell. It's hard to see. Did you? Where'd you pull those from?
Found them in the found them on the scrapyard.
Yeah.
I have only one of them.
Wonder what those are rated at. Those just have 2 electrodes.
Yeah, 2 electrodes.
Do you know what kind of, is there inert gas in it, or is it just a straight evacuated chamber? You know?
They have neon in them.
Neon? Yeah, it's probably
Yeah.
just a big neon bulb, which I mean, you could essentially it could work. I know so the properties of neon are a low starting temperature or low starting rate. Ionizes very easily, but I think that its switching speed is not as great as helium or hydrogen. I
I've
don't know.
tried the spark gap and it doesn't really switch at all.
A spark gap?
Yeah, it doesn't switch very well.
Well, it switches according to the capacitance, right? The buildup of the capacitance.
Um, Once it breaks up, there is nothing to stop it. I mean, uh, it's hard
Once,
to explain, but it's not a very good spark gap.
oh, you're talking for that, yeah, for the neon, yeah, yeah, because well, that's what I'm saying. It has a really low, activation level as far as like heat and ionization. So once it starts, it doesn't just dissipate quickly, and so yeah, kind of get like bogged. You need to like separate the electrodes really far apart or something like that. Play with distances and stuff. Like hydrogen is really conductive, but it has a faster switching speed. Like it will dissipate quicker, and and uh, and helium has a really fast switching speed, but it's not as conductive as hydrogen. And then of course argon is like super conductive, but I think it has the same kind of problems as if I'm not mistaken, has the same kind of problems as neon, where it doesn't dissipate that fast. But I don't know. I could be wrong about that. It wouldn't surprise me if I was wrong.
Yeah, probably the best thing to use is helium, and it's not as dangerous as using hydrogen.
Uh, he, Helium is great as far as like it being able to build up and collapse, and it has relatively moderate, I think, like ionization properties, but it's not as conductive as like hydrogen or argon.
It has a higher resistance.
Yeah, has a higher. I don't know if they consider it.
Well,
Yeah,
basically it is a resistance.
yeah, it is a resistant though. Until it's ionized, and then it no longer has very much resistivity at all, like most inert gases, because it
We can
becomes.
try with different. You can try with different isotopes of helium. I think there are around 3 isotopes of helium.
Or just having a mixture of both hydrogen and helium, because they both have the same molecular density. You know, their material density, or whatever you would like to call it. They both have the same, so they can cohere together. They don't separate. Reverb. Terry's doubling up so he can actually hear, probably.
Come in,
I have
Terry.
that same problem all the time.
Come in, Terry.
When did you get that, right?
Huh?
Radiometer? Is that what that is?
Yeah, Arskoski theory. We can forever figure out exactly who came up with it.
That's cool, man. When did you pick that up?
I've had that for a
Long
long time.
You put in it. Is it close to flares or just in the sun?
It's just in the sun, getting a little bit of light coming through the window right now. Direct light. Laser beam will make it move. It's pretty cool. That's just, yeah, to be honest. And now it's stopping.
Yeah,
The minute we talked about it.
exactly.
Well, all I had to do, I slide it over just a little bit and right back into the sun. As much as the sun's angle is changing right now, it's just kind of amazing. Go outside and look at it. The light's a different color. It's not where it's supposed to be. I've got tons of light in the backyard. That's fall and winter. Everything's about to die outside.
Yeah.
It stopped. That's crazy.
There's different isotopes. You're talking about like helium. There's helium-4 and all that kind of stuff. Yeah. Yeah. Some are unstable. Deuterium is awesome. It'd be awesome to experiment with. They use that. I mean, that has one of the best, not only conductivity, but it ionizes extremely fast and it doesn't have a whole lot of resistance, I guess, is what it is. And that's what they use in a lot of those topomac reactor.
Reactors. Yeah.
Yeah, the reactors they use deuterium and and helium, cryogenic helium to wick away the heat. That's the idea of it, I think. And there's a couple other things that they might break it down into deuterium. I'm not sure. It might go into something else, but interesting stuff. Make it. I saw a while back a guy talking about building one of those little reactors and trying to ask people on the radio to get get money for it, or just to be funded for it, and they were just laughing at him, just making fun of him. But everything he said was was actually like really true according to mainstream science. But I don't know. A lot of people don't investigate it enough, so they just believe what they hear and thinking that the idea of it is that it creates what could be considered a closed system, which I can't really say that ever truly exists, but the idea of a closed system that creates excess heat, and it's not necessarily I don't know, it doesn't, the idea of it in theory is sound like it doesn't break the laws of thermodynamics per se, but it does but it create a evenly efficient system, and that what you put into it, that the fuel for it is utilized to its full extent, and then until
So we're talking about a fusion reactor.
until it deteriorates, you get all just to make heat from it, and then you can, it's like a closed system, right? That's the idea of it. So you can capture everything off of it, but say it's closed is kind of weird because like an earthquake could happen, right? Something could affect it somewhere along the line.
Yeah, but most plasma research can't be dangerous. Nothing can happen. No, really, it can't explode.
Yeah, it's true.
Well, yeah, it can explode. It's a tube filled with gas, but it's not like a nuclear explosion or
Yeah,
something.
it doesn't have fallout and all kinds of other repercussions. It may create some type of like impure radiations. Or I wouldn't say impure, but radiations that are of high frequency or of large waves that can displace
Like microwaves.
matter. Yeah, microwaves or gamma radiation or X-rays. There's all kinds of different frequencies that can be emitted. That's a danger, but there's tons of ways to prevent that. And we get hit with that stuff every day.
Yeah,
Can't
it's
get away from that.
it's not as dangerous as people think.
Yeah, I know. But it's a lot of money, so. I would something I know very little about that I really would like to work on is having heat pump system with using a spark gap and being able to capture some of the heat off of the spark gap discharge. You have an constrained environment. That'd be fun to experiment with sometime.
What's your input on the system you're doing right now?
This?
As in, what?
Me?
Dylan.
Oh, Dylan. All right.
What system? You mean the hairpin stuff I've been exploring? That's pretty much
Yeah,
what
what's the input?
Oh, the input voltage?
Amperage.
The amperage is rated at, well, that's the thing is I need proper meters to really grasp it, but the amps are rated at on the last one I was doing, the 9 kV was rated at I want to say 150. I can let me get my notes. Hold on a second. Maybe I should have. There's silence. So it's 145 watts at 9 kV NST, and it was a 1.5 amps, but it's 30 milliamps on the short. Like when you short it, it's supposed to decrease to 30 milliamps, so it doesn't kill you, right? That's the point of the case grounding. But then,
Yeah, kind of pointless.
right, but it makes me kind of wonder, like, if it's where's the rest of that going? It must be going back into the NST or something, right? And then going out to ground, right? I mean, kind of weird. That's why I'm saying I need meters. I need actual meters to see. Or my old NST was nice. It didn't have a center tap ground. It was only 5 kV. So it was just grounding off the case. I didn't get any arcs off the case ever, which is interesting. But it's supposed to be 30 milliamps at short, and it's a 9 kV. So still, I think it still goes to, I'm not mistaken, it's still like 145 or 150 watts on the up front, and it's lighting up like a 90 watt. I think it's lighting a 90 watt bulb, and then also igniting the gases inside of the conductive hydrogen bulb. I think the UV3 is a hydrogen is what they fill it with, right, Terry? You know a little more about that.
Yeah, I thought it was mercury and argon or something in there.
Maybe it's argon. It's definitely mercury. There's definitely mercury in it that you have to get hot. And then yeah, I guess maybe it's argon. It's either argon or hydrogen. Hydrogen. I know that because the frequency it oscillates at is nanometers is like our hydrogen in our atmosphere actually prevents a lot of that UV light from coming into our atmosphere. So I don't know. I thought it was hydrogen, but I could be mistaken.
What's the spectrum of it? Is it more reddish or
No, it's like UV. It's like it's a UV. It's in the 220. It's closer to the end where you won't be able to see it anymore. It's like it's what they use for water treatment and it's like germicidal air purification. Yeah. Germicidal light, basically.
Yeah.
So I think it's like the 190 to 240 band, I think, something like that. Nanometers.
It's probably some kind of mixture.
Yeah, some type of mixture. Well, I know that it definitely has mercury in it because you can see the little mercury beads in it.
Yeah.
You ignite the filaments, and heat up the mercury. Obviously, it glows a little better and all that stuff. But with the hairpin, like if I put it in parallel across, I can see. I'm trying to use it as like a spectral analysis analyzer tube. But the little coils I made aren't. When I was thinking about the math of it, like stretching it, I was thinking of like stretching the wire out. But when your coil is condensed, to tap it, you have to side of coil. So just tapping it in one linear plane across the top isn't working out very well because it's not. You're not changing the frequency. Like the let your line frequency changes. You're not. There's no way to change the frequency on, or I shouldn't say there's no way, but the way I have it, changing the frequency very well. So I gotta find a way to make one thin line kind of go all the way around the coil, so I can just twist it around or something, I guess. Or just devise a new setup. And I could always just take just 2 conductive wires and just do it that way, like how it's originally done. I was just trying to inductively couple with the 2 coils together and see if that had any effect and move them in and out from each other. And so far, I haven't noticed any significant change. So it was an interesting experiment. It's fun. But the most interesting thing about that whole experiment is just when I put the diode on, pointing from ground into the system, into the bulb increases its brightness, but there's no decrease whatsoever in the filament of the halogen bulb. So that's interesting. And then another interesting phenomenon is that if I turn the diode and I put it to ground, it will just short the system. It basically wants to act as the like the hairpin shorting it. Like it just shorts it on that end. And I haven't set up with the new NSTs that I got. I haven't set up the hairpin to where it has two grounds. If I set it up to where it has two grounds, I'd like to see if it shorts again, because then I think it was Energy Fabricator was talking about how it could be feedback from the actual NST that's creating a sustained oscillation and not just shorting out to ground. So it'll be something I need to investigate to see if it was just my old NST. Because like I said, that old NST, that 5K V1, didn't have a center tap ground or anything like that. It was just a dangerous one-wire NST, basically. So yeah, I'll have to experiment more with that stuff. But what I'm trying to do is get balanced capacitors, and so I've been trying to make balanced capacitors, and then what I keep finding is I'm having tons of losses on the outside, besides cracking bottles, but tons of losses on the outside where it's basically acting like a top load. You can see them, just getting excited and arcing along the glass. So
Yeah.
need to be submerged in oil at the very least. But
I think you should find some other kind of power supply. I mean, totally different from the NST, just to be sure.
yeah, that's a good idea too. Are you talking about trying to? Well, for efficiency's sake, a flyback would work a lot better as far as being more controllable of power in and all that kind of stuff. Like a DC, a solid state Tesla coil is,
Yeah.
is far more efficient than your standard NSTs. I would say far more, but it is a little more efficient than your standard NSTs. But that's something that Jeremy does a lot too, is just to be able to control the experiment more. I would like to run it off of a battery. So when Terry was talking about the medical Tesla coil being ran off of batteries a lot of times, like that's something that I was looking at. I was thinking about building, is just doing an inductive coil. That's why I was asking that question. And then also looking at some of Tesla's circuit diagrams from Colorado Springs. He has a lot of that, a lot of battery setups and stuff like that. And in a sense, he's almost using a battery as a diode in some instances. Like that's what he was. I mean, it was low power stuff. It was not like massive amounts of power, but just to get understandings, he would use batteries in his circuit, almost like a diode in some instances. It's interesting.
Yeah. Hmm.
What you got, Ryan?
I think it's a carbon spark gap.
Yeah.
Ryan.
He's going to make some kind of weird laser fly out of that and burn himself.
Yeah.
We're excited. Yeah. Let's see. We have questions up. Let's see. If anybody out there wants to join us and they have stuff to show and stuff, or just like to ask questions and talk in the think tank, feel free to mention something and you can get added in, all that kind of stuff. No limits to what we can do together.
Yeah.
Like the Lego movie. I'm sorry, I have kids. You know what I'm talking about, Mako?
Yeah.
You do? Oh, Mako. Watch the Lego movie. This is my shameful plug.
Uh, at the moment, I'm beginning to think Ryan is unconscious or something. I don't know.
Well, he's taking care of his kids too, so he's probably got to go get them some food or something like that. Or break up a fight. Jeremy's starting to pray. Yeah, earlier when you were talking about the carbon rods and like breaking little nano pieces of carbon, Terry, like it makes me think about like a electrostatic deposition, of like to make graphene layers. Still, let's see how viable that is. Somebody do it, or somebody do like the what is it, the
Yeah, just
deposition.
avoid breathing any carbon dust, because if it is nanoparticles, it could be like little shards that they say might be slicing your DNA. So
Awesome.
it might not be good.
I have to wear a mask every time.
Yeah, it would have to be HEPA filtration quality mask.
It looks like Jeremy's gonna try an extreme experiment of. You should just take a big breath of that, Jeremy.
No.
That would be a good experiment. No, what is it you're gonna print though? Are you gonna use that in the slurry? No, he's muted.
He lost sound?
Yeah, he's just coming in real quiet.
Oh no, I'm just gonna do a regular print and just let it go with no sound because everything.
Oh. Okay, cool. All right. Let's see if I can turn him up. Yeah, that's gonna be complicated, I think, or not complicated, but there's definitely some type of major learning curve to try to be able to print the graphene in structures that will be usable. I know you can honeycomb print, right? But then how do you get a printer head to make a filament super fine, Yeah, paint, yeah. Oh yeah. So yeah, so now I gotta start coming up with questions because there's so much silence. Maybe I'll just start doing dances. We can start getting silly, right?
All this stuff just makes everybody sit and think about all the possibilities, and you're like, everyone goes.
I think these events might do better with like some beers involved. They weren't so earlier in the morning. Or we just need Ryan.
That won't end up very well.
What's that?
That's not going to end up very well.
Yeah, right. Well, just a few. We have to limit ourselves.
It's too early in the day for that. Right
Yeah,
now.
exactly. That's why.
I mean, even for me, what is it? 3:50. Yeah, I mean, that's shoot. I'll give it 2 or 3 hours, give or take.
I like how beer's mentioned, and all of a sudden Ryan's not silent anymore.
Oh,
What's up with that?
Beer created the world.
No, yeah, right. It could get really bad, or it could get really good. We could all start taking our clothes off, and then.
It's not illegal to make capacitor parts.
Yeah. I had to go out last night and pick up because that bucket cap blew, right? So I had to go out and pick up some bottles of these little margaritas that aren't, they're all natural or whatever, but I don't really like margaritas or anything like that. So I had to slam 2 of those down.
The good old-fashioned.
Those are the only little bottles that would fit in the book.
Yeah, the good old-fashioned way to make a saltwater cap.
Yeah, I need to
I'm
start hitting
no.
up for bottles. 'Cause I don't drink beer. Like I don't really drink that much, so I gotta go. Or maybe I can go to a store and just sit there before they put them in the crushing machines that refund. Like, hey, can I have those? No, it's money, right? So they probably would say no. Maybe I'll pay for them. There we go. 5 cents a bottle, 10 cents a bottle. You guys have that where you're at? You have a bottle return, or they actually pay you?
Not really.
No.
I can get plenty from the rich customers. They save their bottles for recycling. They don't get paid for them. They just have a big box full of them, and I'll grab them.
Yeah, that's what we have. Just giant recycling bins or other dumpsters painted another color, where they get us to separate everything for them, so they can make some money off of it. I don't even. I mean, sometimes I think they just go and dump it. I don't know. I mean, it's just. But you can open up those, and yeah, they've got it already sorted. But heck,
But I
man,
have a lot of ideas with the bottles, and now that I have the bottle cutter,
yeah.
That's
I was thinking of layering the inside with graphite paint or ink, and the outside, and see what type of capacitance it has.
yeah, that'd be cool.
And
You
those
put a vacuum on it.
or whatever, yeah, you could pull a vacuum to increase or decrease I guess that would be the variable capacitance.
Well, it's also like you guys were talking about putting gases and all that. I mean, heck, you start adding different gases.
Yeah.
Who knows? That'd be
Changes the
wild.
frequency.
Yeah. Huh.
Yeah,
But
that's
it
interesting.
may be good for high voltage, or it may only be good for low voltage, but has a lot of capacitance, like a super cap.
Well, I think that the capacitance is well. I think my personal belief in a lot of that is it's really important what the dielectric is because that's where your charge is being stored. So if your dielectric matches up with your conductive material, in that your charge can pass through but not penetrate, the dielectric or interact with the dielectric or the two field presence. Pardon me, the presences on either side. That's where you get your supercapacitors and stuff like that. That's why the electrolyte is so important. And then surface area is important and all that stuff. But as far as like a supercapacitor, or as far as like just regular capacitors, and not electrolytic capacitor or a just an AC, what you would call an AC cap. I think that any type of conducting material would work well, and then the finer the conductive material, as far as its structure is, the more it can disperse an even field. I think that's important. It's dispersing an even field of electrons through or onto a dielectric that is also has a nice structure that it can build up charge on either side.
Right?
That makes
Yeah, it's all happening on such a small
that
molecular scale that's where all the difference happens.
exactly. So to have materials that are interacting on such a small scale as well, create, in a sense, it creates more surface area, somewhat, right? But then also it's exchanging its electron flow in a smaller surface area, or more molecular structure that's more well put together, well organized. Like having a string quartet being in tune or out of tune, as far as they're vibrating with each other. Yeah. But how much vacuum can you pull? Have you been able to pull?
I can pull down to 30 microns.
Oh wow, that's pretty nice. Yeah,
That's about as good as I've ever seen on my vacuum pump. It's 7 CFM.
what's the CFM stand for?
Cubic feet per minute.
Okay.
vacuum displacement.
Yeah, it has a whole chamber for the vacuum displacement, right? Is it like a
The
rotary?
Yeah, it's like an oil submerged thing. It kind of bubbles up through the oil and stuff, and it depends on good fresh oil and all that to work properly.
Huh. All right. I saw some. I saw some just recently. They're like commercial grade ones that they have like rotary. It's like a rotary latch vacuum pump or something like that. But they're really nice for relatively cheap. I'd like to pick one up because this pump that I have doesn't have a check valve in it or anything like that. It's just a surface area. It's just an air moving pump. It's not necessarily a vacuum pulling pump. It's an air moving pump. So once it hits its limit, it doesn't continue to, once it hits its limit as per horsepower, it doesn't continue to pull as much as it can. And then also another chamber would might help too if I set up another chamber that's like a little
Bigger.
bit, yeah, a little bit larger. Yeah, that could do pressure differential. But yeah, I don't think it's not really meant to pull a vacuum, so I need to get a different vacuum pump. I believe so. That's definitely on the wish list.
Yeah, look at pawn shops and things like where people have got some of the older ones and pawn them or whatever. They'll
No,
probably sell you pretty cheap.
I discovered this place called, or I didn't discover it. I was told about this place by two people, Jim and a neighbor across the way. And they both said, you got to go to this place since you're into this stuff. And I finally went there, and that's where I got this NST for $40, right?
Well,
I know it was a good deal. And then they have these, like I said, these industrial vacuum pumps for laboratories, and they even had a little vacuum chamber and everything. That was like the vacuum chamber was like $40, and the pump was like $40, which is crazy to me. I think the pump was $50, and I don't remember how many microns it pulled, but it was a nice looking pump.
if it was a laboratory grade, I'm sure it exceeds what the air conditioning industry really has to
Yeah,
do, I would imagine.
yeah. And they had like 5 different ones, but they also had this thing I drooled over. It was like $500. It was a Marconi FM signal generator.
Oh, wow.
Yeah, it was so nice. It was analog. It was all analog, so it was old school. Looked like something I had in his laboratory. Only he had mostly military stuff. This is like a private company, I guess, but it's still really nice looking. Everyone's dropping off.
We lost Abrams.
Yep.
My phone died. I had to switch to my tablet, and it doesn't pick up light. Unless I'm outside, then the camera works all right. The megapixels are not good at all either.
Yeah, so it's all blurry.
Yeah. So I'm charging my phone. I might switch back to it if y'all want to see the big Tesla coil run or something.
Sure.
Anyone's interested.
You have Crom, is that what it is? Crom running?
Yeah, well, it's the Eye of Chrome.
The Eye of Crom, alright.
Yeah, that's what it really was. It really was from the beginning, but we just shortened it with Chrome, I guess, over the last year or so.
Is it 3 or 4 microwave oven transformers?
It's 4.
Yeah, that's nice.
2 are submerged in oil because I'm actually putting the output of the first 2 into the core. So the core sits at 2,000 volts, give or take, on each one of those, and when they're at the opposite phase, you have 4,000 coming out of each one, and when you have the phasing right, you have 8,000, give or take.
8,000 at like what,
At
600 milliamps?
oh, if it's unballasted, you're looking at I don't know, give or take 2,000 milliamps or something.
2 amps basically.
But if you ballast it, like mine, I've got it down to, so far I've used it all the way down to 20 milliamps.
Oh
The
wow.
same setup. So if it depends on your ballasting.
Are you ballasting it with those fluorescent light ballasts? Or are you actually using other? You're actually using other.
Oh yeah, I forgot about that. That fluorescent light ballast, I'm sure that was less than 20 milliamps. That
Yeah,
was probably more like 10.
yeah.
And that was only 2 watts.
Okay.
But
So
the big one's capable of running, you would need 100 amps at 120 volts to run 4 mods if you had them unballasted. You would have to connect it straight to your meter. Like,
that's a lot of power.
you have to have big thumb-sized copper wires feeding them and stuff to keep from melting.
That's crazy. Just go.
But
Just go.
I'm using electric heaters. I'm using electric heaters, which are rated at 5 kilowatts each, and I can adjust all along the string to reduce the actual wattage allowed into the mods.
I see. So it's like a
So
adjustable resistor. Is all.
not,
Is what,
not only that, I can place the whole circuit in the dielectric realm by using capacitive ballasts, which seems to increase the output while cutting the amp draw in half.
let's see.
And the
And for
more
the capacitor.
capacitors I add, it keeps doing more and more. So I'm sort of collecting them and putting them in parallel with that. And it's not increasing the amp draw, but it's increasing the output on the Tesla coil.
Well, in a sense, I mean the mains power is capacitance too, right? So you're kind of just making a micro capacitance in your
Yeah.
capacitive ballasting, yeah. And then you're not breaking through bottles because you're using higher amps and lower volts, right? So it's not. It's interesting. And
Yeah,
they,
because the voltage, I guess, is still the same.
yeah, exactly.
The amperage is less, so it charges them quicker.
Yeah, the fill-up rate is super fast because they're only like maybe per bottle is what, like 1 nanofarad.
Yeah, at the most. Yeah,
Yeah.
if you're lucky.
Yeah, usually like 800 picofarad, right? So
Right.
yeah, that's cool. That's interesting setup. And you just have it off a 240 mains.
240, and then if you send that voltage straight into an AC cap, 60 microfarads, 120 microfarads, 240 microfarads, it has to go into the dielectric realm before it hits the actual circuit for the mods.
Ah, I see what you're saying. You're using a filter. You're using
Right.
like
2 of them,
motor
on each
start.
layer.
Oh wow.
It has to
Oh yeah, because you have to
actually
run off a
it's
240.
in parallel with the mains. It's in series with the mains. But if you look at your hairpin circuit, that's what it is, except the MOT's in there rather than a light bulb.
Right. That makes sense. Yeah, I have one filter cap off of the 120, but yeah, that makes sense if you're going 240 to do that. They're
Yeah,
just
it
like
really-
motor start caps. Is that what you're using?
It would be the permanent capacitor type motor capacitor. Big compressors use them, and
Yeah, for starts.
everything's single phase. It has that start winding, and it uses the capacitor to make Tesla's invention. It's another one.
Yeah, one of many discoveries. It's one of his discoveries.
Right. The way he learned to wind those AC motors, we still use to this day in almost every AC motor.
Yep. Yeah.
And the
We're
DC
starting to.
is electronic, the ECMs, the X13
Yeah.
was Tesla. You know, he had the mechanical oscillator that does the same thing as the MOSFET does now.
That's what I was about to say. We're starting to go more and more towards the pulse DC style motors for efficiency, anyways. But there's some things they can't do, like for large scale work. Like, I don't think you're ever going to be able to get away from the big, ginormous single phase or 3-phase motors that deliver 5 horsepower or whatever.
Right, because they last forever. You know, they last,
Yeah,
and they're made to.
they have no components that break down.
Yeah, it's
All
simply
except for the
bearings.
bearings. Except for the bearings, exactly. I mean, if you have magnetic bearings on those, they never break down. Or, well, I wouldn't say never, but you could overheat the coils or whatever if you run it wrong, but never break down. And then most magnets last for, well, I don't think they really have explained how long they last, but what's been said is like 400 to 500 years before the rare earth neodymium style magnets, before they start losing their Tesla, or what's the other word for it? Their Gauss. How much Gauss they have. It's interesting. I was like, Ryan's dealing with some kiddos. Yeah, yeah. As far as the transmitting power, though, going back to that, I think this challenge is an awesome idea. I'm glad Jeremy was leading the way in that, or trying to encourage people, because hopefully open up more ideas. Nice. Yeah, Gendron too. No magnets or coils, but you still have some decomposition in the arcing of the electrodes. But who knows how long? I mean, that doesn't seem. Again, that doesn't seem like it would decompose that quick. It'd take a long time. Yeah, I figured. Audio seems to drop out a lot, so if anybody's wondering, I'm reading some of the chat on the side. I think that you can see the chat in the actual video when it's no longer live. But what do you say,
back to my mobile.
Cool. It'd be an interesting setup to do. Use inductive coil, like a medical style coil, and then have a adjustable spark gap off of that into decent sized capacitor, and then have completely matched in capacitance and inductance another coil, just to see how far you can bring it, be able to attach it into ground, like like Tesla's patent, with his pancake coils, or the apparatus for transmitting power. It'd be nice to see more of those experiments out there. That's like this pancake coil I made is just one of 2 of identical. I'm gonna start to play around with that. We'll see if we can get it done in time. Contest.
Yeah, a lot of cool stuff happens with those.
Yeah, bifilar. So we'll see. It's pretty much dried, I think. Yeah, it's getting there. I gotta wait a little bit more. But I don't know if that coil. It's a solid copper, 2 solid copper wires in there. I don't know the exact thicknesses of them, but it's power limiting cable. So, but it's just surface area that you deal with, right? I mean, that's really the most important thing, is the surface area. So after I wind them, in order to get the primary correct, I'm gonna have to do some of the math, or centimeters in centimeters for surface area around and length of the wire, and then square it, and all that kind of stuff. Have you ever done that? You ever do that crazy
I have
Tesla math?
tried and tried.
It's annoying, man. I don't like math. I like just playing with stuff. I wish I didn't. But in order to truly understand in order to be able to communicate it, a lot of times like, you got to have some math behind it just to freaking be able to explain it to people. As far as I mean, that's all math is just a form of communication. So as far as mainstream
Well,
scientific,
luckily we have apps that do it now.
yeah,
On your
actually,
phone, you can plug in all the information you know, and it'll spit out a frequency, and
yeah,
it'll be close to what you're working with.
yeah, that is very handy dandy. And calculators are nice too. Nice to have a good scientific calculator. You can get your
Yeah, yeah.
square roots of
I didn't
things.
make my job just because I'm terrible at math.
I just I never really got into math except for like geometry a little bit, and then when after you start playing around with this stuff, like you start realizing, oh, you really have to, if you really want to understand it, sometimes you have to look into um, different terminologies for what things are called in math, like yeah, all the different symbols, delta, alpha, beta, all Greek the Greek symbols, so you can understand what some crazy physics dude is actually saying. So off the receiving tower, you put a diode, Jeremy. Up, yeah. So,
Very
so when
interesting.
you hook it to ground, do you hook it where the diode's pointing to ground or where the diode's coming up from ground? 'Cause I had the same type of pointing to ground through, and then so you're measuring it, what's going from your receiver down into the ground. Have you switched it the other way to see if you're picking up power in the opposite direction? Nothing that way.
Very interesting.
I will mute the noise.
And the meter is on the opposite side of the diode, right? So it goes from your receiver to your diode to your meter to ground, and not linear. Yeah, yeah, that's picking up power definitely. 15. Yeah, yeah. Yeah. It seems like mass or matter almost facilitates, yeah, ground current or just matter in general. Because you look at a wire, and if you have too small of a wire and too much resistance, you get a lot of excess heat, and the wire breaks down, things like that. So the same could possibly be said with the Earth, in that it's so large that its spatial field is actually affecting all of the energy around it, right? And massively coupling with something else. And so I don't know, like it's almost like that's how current is derived, like energy moving through space. Energy moving through space alters its field and creates a field presence of some sort. So it's what's your power going into the receiver though? I mean, the transmitter. Pardon me. How many milliamps into the transmitter? I wonder. Yeah, it's definitely nothing else. There's something to learn from there. Looks like Terry's powering up the eye of Grom.
It would be funny if we can hear it.
Yeah, be nice and loud.
You want to hear it?
Yeah.
Yeah.
Yeah. To the diode output or the ground loop on receiver.
I'm surprised my phone hung on to that.
Yeah.
That's cool.
I can't turn mine. I can't turn the upside down when I'm.
My family will be coming down yelling at me in a minute.
So the circuit is a tad stronger. Took directly. Let's see, ground loop on shows the same thing whether it's hooked to the diode output or the ground loop on receiver. Directly to the circuit, it's a tad stronger, but not much back in. So you're getting 15 milliamps off the receiver either way, though. But it's a tad bit stronger through the light output of the fluorescent, or are you getting increased current when you hook it up to the ground and the ground loop of the?
You got any sound on it now?
Yeah, a little bit.
I can try and explain it. It's a little easier without trying to do it in text, even if it's hard to hear. If I hook up the ground rod, let me see what I'm looking at here. This ground loop, what I'll do is hook the red of the meter to the ground, the black of the meter to this ground loop on the receiver tower, and the meter will show microamps coming through. It's the same thing as if I go over here and I've got a high voltage diode coming off of the collector here. If I hook, instead of hooking the meter up to this ground loop, I hook it up right to this diode, is almost exactly the same microamp measurement.
Does anybody
But
else?
it cuts out, like,
I'm not seeing the video, but it's probably showing up on the. Like it'll probably show up later on.
it's kind of hard with we're kind of having problems communicating here, but basically like the back EMF from the that you would use similar to a Joule thief or a Bedini circuit or something, the back EMF that you try to capture. When I send that back EMF from the Slayer into ground, and I'm only running off of a battery, right? But if I send it into ground, it's showing current coming up from the ground. It's coming up in reverse. The same thing as with the ground loop. So, and it's seeing the same value makes me think, well, of course it's related. Of course it's the same thing.
Yeah. Yeah. You have you put your transmitter, it's completely isolated. It's just hooked up to the battery, right?
Yep, just battery alone. And when I ground it, it totally kills all the effect. So, I don't know. There's a huge mystery there. I've tried to talk about it, but it's hard to see without seeing it in person.
Yeah, I know exactly what you're talking about, man. Because like I said, as I'm running into the same types of phenomenon where it's like,
yeah,
I don't know. It's like the ground is actually it's part of the space that we're moving through, right? Because we're so close to the ground, I guess. Or I don't know. It's hard. You can come up with a bunch of theories behind it, but
Like the copper rod that I used in that field experiment, that was a 6-inch copper rod. It was almost nothing.
Yeah.
So, yeah, I don't know.
Yeah, it's really interesting to think about. It's like and it's like that's where the current's coming from.
Yeah.
In that sense, if you make it just a one-way type of situation, and it's AC, right? I mean, basically, it's alternating currents that are coming from the transmitter, right? So then when you attach the ground, I don't know. It's really interesting. It's like you've imbalanced spatial field and it's trying to find rebalance, and so it brings in a magnetic current from the Earth to try to rebalance it or something. Like, I don't know. There's tons of different ideas or different ways to explain what it seems like is happening. Anybody else have another take on that?
No one wants to give out any secrets.
I guess not. I don't think they're secrets. They're probably just all thinking about it. Like, well, I don't know.
Secrets.
Yeah, it's interesting.
For you, Abrams, what are you always doing over at the window there?
What window? Which one?
In your lab.
I don't know. Not much of a view or anything. Just the woods. What am I doing? Window.
The back door? The back door? Is that what you're talking about?
Yeah. Yeah. I didn't see it too.
Yeah. It's my outdoor bathroom. Keeps the bears away.
He's putting his scent. He's marking his territory.
We all know your secrets.
Yeah.
Hey.
You know what I think it is? Is he put his ground rod right out there, and he's just giving his ground rod some electrolyte.
Exactly.
Oh, yeah.
More
It
content.
is right there. There is one right there, to be honest. It's like 3 back there. Then there's one or 2 going into the front of the house, and then there's the one for the house. So, oh, and then there's one for a dish satellite. So there's all kinds of grounds.
I got 2 old dish satellites right on my roof pointing south, and they run right over above me, and I've thought of just snipping one and trying to use it. Think I get in trouble by transmitting with the satellite dish?
Unless it really started messing up stuff. I mean, that's, you'd have to be really, I don't know, people used to, I mean, think about when the big old satellite dishes came out back in the day, they had, de-scrambler boxes and picking up channels from all over the world. I don't think once you start interfering on certain bands is when they get mad at you.
That's the thing, is that I'd have to look into what band I'm broadcasting on. That's really important. And then also there's you can do a what do they call it? Give me a second, it'll come to me. Not a bogged frequency. What the hell do they call it? What's its terminology? I forget. There's a way that you can a dampened. You can do a dampened signal frequency. That's what I'm thinking of, where it's not spread out over larger portion of space, and it's not just direct beamed with a large amount of amplitude going into certain other areas of frequency band and piss people off.
Yeah. Well, it's like we used to have a big wind turbine up on this mountain right in town. It's like the biggest. It's overshadows or overlooks the whole town, and it was a NASA project, and the blades were like a football field. At the time, it was the world's largest. I think it's in Hawaii now. But when that thing would start spinning around, it didn't even look like it was even going, that fast at all. Everybody's television reception would go off.
Oh, really?
Get all messed up. Yeah. So, I mean, it was a first design. This is back in the 80s. So, but that was the biggest. It was just I guess back EMF from those whatever they had it. I guess it was magnets and coils. So on a huge scale.
Yeah.
Up higher than everything else. All the radio towers and everything were up there too. But heck, man, that's probably where the interference was coming from. So.
Well, it's interesting. I'd like to send it's smoky.
The smoke is rolling in.
I'd like to send a balloon kite or set up some type of tower or whatever, and experiment with upper layers of the atmosphere. It wouldn't take too much as long as the antenna was designed properly. If you're dealing with quarter wave transmissions, I don't know. I gotta do a little more research. I've been dabbling in antenna transmissions and stuff like that. And but if you go up a certain way, it's like it becomes conductive. The ionosphere or whatever layers above us are conductive. That's why the sky is blue in a sense. Like the cosmos is delivering tons of RF and other radiance, and we're like our own isolated pressurized vacuum chamber floating through a reverse the opposite end of the vacuum, different pressure differentials. But it'd be interesting to see if you increase signal strength. I know if you have a longer antenna, you'll increase your the amplitude of the wave you send out. But I think it's different in radio frequencies. I think that the more potential you use, the farther the signal goes, rather than how much power you use at once. The current itself. I could be mistaken there, but more dependent on the mass of the antenna itself. Kind of like top loads too, same principle in a sense. If you have a quarter wave antenna, like an antenna that is designed properly to your frequency that you're delivering in potential and your coiling, right? Or even a third of its mass. I don't know. I'm just thinking to myself now. I'll just stop.
I'm listening. I just know the minute I turn this coil on, it's just going to shut that computer off.
Are you going to turn it on?
It might not. I mean, I keep thinking about putting some kind of cage in front of it. Hey, that's a good idea.
Put it in a microwave. You got a spare microwave?
No, here. I don't know. Something like that. Probably come out and strike the damn thing. Yeah, and clean all the smoke up in the room real quick. Maybe. Not on. I have that all hooked up. That's funny. It's usually, always.
There you go.
I don't know if you guys are still there. Just switched the screen on the computer. Yeah, you guys are. Just changed it. Just took you guys totally off the screen. What weird. Fresh, clean air. Now it smells like a swimming pool.
Like a crazy, you have a
Huh?
crazy tiki or alien dude that lights up.
Which one was, what was lighting up? Something? Huh? Oh yeah, that's because that's where the spark gap is.
What
That's Derek gave me that blower out of something. So
what'd you
I got
put, Jeremy?
air intake coming in here, outtakes coming here. So I've wanted to
I
put
see.
another spark gap up here for the suction. It's kind of how Gary's got his set up. And then I've got two 9,000 volt NSDs. Relay switch, 24 volt AC transformer for 120 for the air diaphragm. All Terry's idea, but it keeps me from being electrocuted. Because you know how much I like being electrocuted. Even though I'm stupid and I don't use it when I should.
Yeah, but my blower motor doesn't have it only has an output. It doesn't have an input. Like it's just open on one side. I have to.
Well, I just put a tube. I found a piece of PVC pipe and just extended it out. You know what I mean? If there's a little lip or something, you can get something around or connect it, and then just take some duct tape or electric tape and seal it up.
It's completely open. Oh yeah, I could like seal the entire thing up. I have to get like a piece of wood or something, or a piece of plastic and seal up the entire thing. Like it's completely
Yeah, like or
open
just
almost.
go around. Cut like a bucket bottom off of something and go around and just like epoxy it to it, and then you have I know I don't know what that motor or what that blower came out of. Probably some type of heating unit or something. So,
I
Terry
gave
knows.
Jim another blower that was a little bit nicer.
Your blower?
Yeah, what'd that one come out of?
That's an insert for a draft in the flue pipe for gas furnaces.
Okay.
Like if they have a horizontal pipe that don't naturally draft, you have to have one of those.
Huh.
So it can take high temperatures and stuff. It's made for it.
It's got a couple of them. The more air, I mean, that's something Terry and I always agree on. It's like you can't have enough air. I've been wanting to take the air compressor and get another tank, a holding tank, and be able to shoot, 80 psi through the spark gap, really, really close. Yeah, I just see, you know what I mean? Because I don't know. I've heard stories of people doing that, and that's with like mod systems.
Brake rate that you're adjusting.
Yeah.
Yeah.
And be able to, and if you had a nice ball valve or some ability to really be able to sit there, a couple ball valves and be able to fine tune it to just a nice straight, blow, and having it blow exactly where you want it too. That's the other thing.
Yeah.
Do you want it blowing through it or over both? I mean, it really does make a difference how that air is hitting that, so, I mean,
There's endless possibilities there too. You could make a plastic container that has multiple with air blowing in, it twirls around or something. Who knows, like that Tesla check valve thing happening or something,
Yeah.
Yeah.
Oh, and the idea.
Little tornadoes in the corner.
Yeah, like like we've talked about before, the Tesla's. Now I'm pulling a brain fart. The rotary. The rotary. What were we going to use? Tesla's turbine. Tesla's turbine. Air powered for the spark gap. I think that'd be pretty impressive. You could use that air tank for that basically, and then you drill holes.
There's more potential than that. I mean, there's like you could do a bunch of different pressure differentials. You could do different RPMs. you can also use it as it's almost like a variable capacitor, a spinning variable capacitor in a sense,
Yeah.
just by adjusting the distances of the discs.
And then putting them in a vacuum. You know, I keep thinking about putting a rotor, putting something in a vacuum. You know, it's not just a stationary standard gap. You know, something spinning, something doing something. I don't know. It's who knows? I mean, you're not going to get. You know, you can't have that thing spinning with air inside a vacuum, but you could definitely.
Well, pressure differences. That's all air is you're moving.
That's true.
Pressure through you're unbalancing pressure. That's all you're doing by moving air. It's all pressure differentials. It's all potential, you know, just differences in potential. So there's if you pull a vacuum and then you have the outside air has more pressure, then it will pull through the chamber, and then you know there's your potential difference. You know, you're creating a potential difference. There's lots of possibilities for that too. There's a later thing that Tesla didn't even get patented because nobody would patent them anymore. But was his part of his death ray or whatever it was. We actually he set up it's like an apparatus that had its own self-contained pressure differential, in that it would create opposing pressures from the outside and the inside of like, it was like almost like a laser tube or something. It was crazy looking, but he just drew it up. And I don't know if you've ever seen any of his handwriting or his actual artwork, but it's terrible. He definitely was not he was not an artist in that sense, you know, like drawing things. But it's interesting to look at. It's really I wish I had the link.
Terry's twin brother's on the call, man. It's Larry Woodruff. Anyway, there's Larry, Terry. Bitco is like, why is there two Terrys on here?
A tablet and the phone, which phone actually see me, but the tablet can't. On the dark with this light.
Gotta love it.
I've had to do that too. My computer connects nicely, but if the missus is using her, I'm on hers right now, but if she's using this one, I don't have a camera on my computer, and so I use my phone, but I can't hear anything if I use my
the call on the tablet. It didn't end the call.
No, I know. It did. Oh.
Yeah, but
what are we doing? What time is it? Ugh. Jeremy split, didn't he?
Yeah, Jeremy took off. He said he had to go into town.
Print done. Uh-oh. Now we talk Harry, Larry, Gary. That's fun.
I think if anybody else wants to like organize this or whatever, and I'm totally down. Like I don't have to always be the only one to do this. But, I think if we space them out like a month apart, it might be better until we get more people who want to share things. Because right now it's just us every week or every other week or whatever. I feel like I don't have enough to show. Need more work done.
Kotus is asking, how long are we going to be on air?
I don't know. That's up to Guiden.
It's up to you guys. Oh wow! Now we have questions all of a sudden. They just all popped up.
Really?
Oh, here we go. Yeah, I got questions. Sweet. Let's see, has Ryan or anyone besides Dyden gotten the tornado effect? Oh yeah, definitely. I've seen you have it before.
Yeah,
That's a huge one.
Yeah, Terry do it.
Oh, it is with the round top load. This
Yeah.
on
Seems to happen a lot better at cooler temperatures. It had to happen a lot more when it was
you have
cold.
to have really still air.
Yeah.
Yeah.
That's true.
really still air, and it seems like the
Yeah,
shinier,
be still, turn it on.
no pits, and then yeah, a circle. Yep. Yeah, that's from Jim.
It is appropriate to put me in a cage. I'm starting to read these things. Yeah. Cool.
Well, if you,
I really want to try that Tesla turbo.
yeah, the Tesla turbine, the boundary layer.
Yeah, I just think air pressure. Yeah, just being able, because you get lag regardless. There is a lag, I believe. Once you on the rotary spark gaps, no matter what. Once you're putting power through them, there's got to be something that's going to happen with whatever. If I put anything more on the one I've got right now, this little teeny one, any more power through it, I'm saying, it's only 4,000 volts right now. It would just arc off. And I told you what happened when I tried to use the power source, the DC power source.
The rotary spark gap.
Yeah, it jumped right off into the motor, and then tried to jump into the power source I was running it with. But if I run it with batteries, it doesn't do that at all. It's because the ground probably. I cut the ground off my power supply. I probably won't do it. I don't know.
Right. You probably shouldn't do that.
No, yeah. I'll blow that one up.
They're just
Find another one. Or build one. I know. Everybody start yelling at me. Build one. So.
Yeah. I know with a rotary spark gap, there's like two primary types, right? There's a synchronous and asynchronous, but the synchronous is with a wall power supply, like it runs off of what the power supply is running off of, right? So you have to find or create a motor that's in phase with, you know what I mean, with the
firing. Yeah, exactly. It's got to be. I know. Yeah.
fire.
Exactly what I'm talking about.
Yeah, that can be tricky sometimes. And then in asynchronous, it's completely out of phase or whatever. But an asynchronous is easier to make, but harder to get the frequencies right, I guess, on a rotary spark gap. For the discharge of your capacitors, for it to be at the right place at the right time in the spin. This is from stuff I've read. I played around with it would be an asynchronous spark gap with a Bedini, with my little ugly Bedini, and I just completely fried I was running off of a reed switch, completely fried the reed switch and destroyed the whole thing. Kind of silly, but I was having fun. I blew it up.
That's half of it.
Just blowing crap up, right?
Yeah. Hey, what, having fun and blowing stuff up? If you weren't doing that, then you probably aren't learning anything. So,
Yeah, that's true.
I blew it. First time I ever really tried to do something with a rotary spark gap, or the second one I built, I blew up one of those 9,000 volt NSTs. Because of the firing rate or something on there. I flew back in it and just burned it up. So.
Get him in here. There it is. I didn't even know he was watching.
Who?
Mr. Price.
Terry's got his stuff. Or is that Jerry? It may be Larry. Oh, God.
There you go. Yeah, if Jim needs an NST, maybe he could get one at this place again, or any of you guys, because they're super cheap, only like $40,
Yeah, and then they'll fit in a medium flat rate shipping box. That's $12.40 something, 43, 48.
Yeah.
So that's
just the weight that's getting
$50 bucks. Well, no, that medium flat rate, you can put 70, or I don't know, I think it was like 70 or 80 pounds in one of those. So you can just put lead in it and ship it, a bunch of rocks for $12. So.
All right.
That's how I used to ship my NSTs out in those boxes.
Yeah.
Shit.
I don't know. I don't know if he'll join because he's got a very weak internet connection.
Hmm.
You know what? I just thought of something. I thought this would work.
Mm-hmm. Mad science.
What's that? Yeah, those are too. Those are too small. That's a bummer. Too small. Make a little Tesla turbine out of the pipe cap. CDs are too weak, so I was going to use hard drive platters. It's too big. Everybody's muted except for me. Yep.
Crap. My Slayer did something to it.
To your foam.
Yeah. I had no touch screen effects anymore for a while. I was trying to get the little spark gap Tesla coil to again off the pancake off the Slayer, but I added top load to the receiver tower in the form of a
Yeah.
heavy gauge, and then
It's a heavy gauge wire.
it's a heavy gauge wire. I'm not sure what it is. It's maybe 16 or 18 gauge on there, and it's a half-inch PVC tube. Electrician, well, it's half-inch inner diameter, so the outer, I guess it's 3/4. Actual 3/4, and of course it's on top of this one. And then it's on top of the pancake, connected to the earth ground, which is up here. And sent it to the flyback. These two yellow cables straight to these two terminals. The actual internal windings.
Right.
Built-in primary of the flyback. And that's what makes this pancake coil work. And you can just place a Tesla coil on top of it. You can move it around. And you get sparks out of both ends, of course, unless you ground the bottom.
Right.
And you can place
It's in
a
its field.
smaller one. It'd be good for electrotherapy because it's very light tingles.
Yeah.
With adjustable frequency.
Is it And it's just inductive coupling. If you attach a ground to it, does it add any more current draw?
Here's
Make it
the ground right here. It just makes it all come out of the top.
Yeah.
So,
Doesn't decrease the size or increase the size of the actual discharge. Lost them. It's like Slayer must have killed it.
it's ridiculous in here.
There we go. Lost you again. See, Jim's got some more questions. I was planning on running my L3 self-looped from what would be the primary in the original circuit. Any suggestions? Self-looped from what would be the primary in the original circuit. The primary from the oh, I see what you're saying. Looping it back in to the primary winding. With a Slayer, maybe a diode. So the primary windings don't just jump into L3. If I understand the question correctly.
I get knocked down, but I get up again.
Experiment. Oh.
Yeah, it's I need some kind of old camera or something I can run through a couple of filters and or maybe like Ryan said, a Faraday cage and have it grounded. That way you can just move around and have Faraday buttons, I guess. I don't know, to turn it off and on.
Just wrap
a touchscreen device.
Wrap the whole thing in aluminum foil, except for a little camera hole.
But then, of course, I wouldn't have a connection.
That'd be the problem.
It would block the microwaves, wouldn't it?
Yeah.
Normally transmit out of my skull as an antenna.
Let's see. Comet. He's comet bombing us. Hey, at least someone's saying something out there. So yeah, he wants to loop back his L3 into his primary. Any suggestions on that? I kind of gave my 2 cents. What do you think?
If you connect it to the primary, it does feedback. That's why that circuit makes your battery last like 3 to 4 times as long as it should. If you calculate the milliamps coming out of the battery, it should be dead. And then it'll last 3 to 4 times as long. So L3 is one of the keys to the spatial energy coherence, like you were saying earlier.
Yeah.
When you get these circuits tuned and resonating properly, of course, that's where the magic is.
The magic.
It is magic.
Yeah, right. Because we don't understand it very well.
Yeah.
Using L1.
My QEP, you know? It's magic.
The QEG.
The QEP. The quantum energy potato.
Oh, yeah.
Magic.
Magic. The L1 is being used as a step down, and then he's using that as the voltage to run the L3. What you're stepping L1 down from what? What's your supply in? What are you driving with? The Slayer?
The when you drive the Slayer, if you know that the one I've got set up will run from 9 to 36. I haven't pushed it beyond 36, and I'm using a 2N3055 from Radio Shack, the one in the can.
Yeah, MPN. Yeah, just the general purpose one, right?
Yeah, I think
Very
it's good for
now
15 amps.
is in. Yeah. All right, show.
Hey man,
Senor Bryce.
Yeah.
Brother.
Ta-da. I'm doing good. Doing well. Trying to get through with the question box was a little frustrating, and I don't know how well you
Yeah.
guys can hear me. So if I sound like a broken robot, please forgive.
Sound good right now.
that was
Okay.
clear.
Yeah, I want to clarify that L3 comment. Having your L3 uncoupled, like no connections whatsoever, fully wireless, could you step down into what would be the L1 in the original circuit, okay? And then loop that back to excite the exciter again. I know that I've done this by I had a 12-volt Slayer exciter running, and I brought in the circuit that could handle 1.5 volts, and the LED lit, so I knew the circuit was active. But I was thinking along the lines of chaining these together, you know, bringing L3 in quotation marks into the field and having what would then be the L1, without a diagram, this is a bit of a bitch, but using what would be the L1, your primary, as a step down off of the L3 to self-activate L3 to then create a larger field to put another coil in the way and do the same thing. Does that make sense?
So
Yes, because the voltage simply the voltage that comes out of the bottom here, this is technically not L3 because it has no physical connection to the Slayer exciter here. No physical
Yeah,
connection.
what I've done with sorry, Terry, I don't want to interrupt, but my connection's so bad. I hear half of what everyone says.
This is the same as your primary. This is the step down. It steps down this high frequency, high voltage to a low voltage, high frequency. That's why it's capable of running a flyback simply by connecting it. No rectification.
right.
It puts out high voltage on the flyback. So, I mean, you could easily charge your run battery with the output from this step-down transformer. That's basically what you're saying, and you did in your video, which is how pretty much I saw your video not that long ago that was doing that very thing.
Oh, you play guitar also. Good man.
Yeah, check it out. I made one, a bass guitar. It has
I saw
rubber
that.
bands. Yeah, the piezoelectric. Got your plug.
Fun
Pretty
stuff.
awesome.
I've noticed that people with the creative engineering minds, we all tend to be musically inclined. We could have a killer band. Killer. Yeah, probably like electrocute all the people from the front row back to the 20th. It'd be awesome.
Yeah, we could send up put some Tesla coils, right?
Exactly. Everyone's grounded. You have to put on chainmail to come into the show.
Lightning bolts to your hands. Or your guitar itself. Drumsticks. Gotta get some conductive drumsticks.
Exactly. So
Yeah.
my point was, I can run my pulse motor totally wirelessly, no ground, from 4 feet away. And granted, I had a 4-foot fluorescent tube in between my L1, L2 setup and my L3 tower. But then I did a step down. My L3 also had what would be the primary. Okay, it was like 4 turns or whatever. And I was able to run my pulse motor off of that after going through rectifier and a cap. But what I was wondering was, do you guys think it would be possible to loop that instead of going to the pulse motor, going back into the L3 circuit and creating another SEC field to act as a transceiver?
Yeah, I think that'd be possible. It'd be like it'd have to be more likely. It would naturally create like an out of phase sequence between the two, and
Right.
oscillations between the two.
And that was my concern, was not having the in happening while the out was happening. To not stuff my own airwaves and let things flow. I wasn't quite sure, maybe just a diode in the right place would make that work. But I have not tried it, so it's just like a mental question.
Well, you looked at the SEC stuff, right? The Dr. Stifler stuff. We were talking about that earlier.
Oh, yeah. But having an unknown, something you can't see or place a color to or measure, makes it a little. I'm a very visual person, so I have to have visual results before I feel safe to continue. Sometimes it's weird. But I'm. It's just a mental construct that I haven't personally put together. It's not that I'm out, buck-fishing for a resistor or transistor. If I try, that's not an issue. It's just I haven't done it yet because I'm still trying to mentalize the whole thing. So,
yeah.
Anyhow.
Understanding the invisible is a tricky thing. You could use fluorescence. That kind of helps.
Right?
You see the wave. A lot of times, there's spectral analysis tubes. You kind of, you know what I mean?
They really are. You see the standing waves, just holding the thing there. That is such an incredible feeling.
Yeah.
Yeah, I dig it.
The looping it back into the primary, though. You're talking about when you say L3, you're talking about the actual receiver coil, right?
Yes.
Stepping down, looping it into the primary.
Yes. The primary that is set around the L3.
Maybe if you make the primary inductively coupled, like 2 separate primaries inductively coupled. Does that make sense?
A bifilar?
Like bifilar, because if you have the interaction between, even if they're out of phase, like you're still getting different peaks in potential in the actual conductor. It limits its space of where it can go. Whereas if you inductively couple it, it won't limit its space so much.
And that
builds up its.
I was thinking about a cap. Oh, I'm sorry. I, I was thinking about a cap in series with that, just to, it's like, okay, here's my build up, here's my discharge, and I
That would
can't.
be another. Yeah, put a cap in between so they have some type of dielectric separation.
Right.
That makes sense, because if the currents interact with each other, they're going to dissipate into the spatial field around, and regardless
Yeah.
of what you do. That's just what it does, right? So if you have, I don't know, if you have phase changes that are 90 degrees from each other, I don't know. They're gonna the trick is you're gonna get the same, unless you like the cap might help, because you might get like a reverberation, in that they're oscillating back and forth and being out of phase. But for the most part, like, they'll be in, like what Terry was doing earlier. You can see that it was in phase with the flyback, and when he put his hand up to it, it affected it. He was grounding it out, and the whole system seems to be in phase. So to get it out of phase would be the that's gonna be the interesting part. So
I wish I had a dial that said 90 degrees, 180 degrees, 270. I can just like switch that shit. Like, no, I want to
It's
see
an
this.
oscilloscope. Lots of time on your hands.
Yeah. Not
I think
happening yet.
Yeah, well, I think that's what Dr. Stifler was doing, right? Is a lot of his waveforms were like that, where he was trying to get his receiver to go out of phase with his transmitter, and then he was kind of like looping the energy back through, like.
That's one of the things that Bedini tried to stress, is that you could not charge a battery while you were discharging the battery.
Yeah, you can't go. It's the same with a copper wire. You can't go, because all things have a magnetic direction. You can't go too directional in that. You see what I'm saying? Like in a conductive realm, it would have to be close, semi-conductive or dielectric in order for you to go two ways back and forth. Because it's really, the AC is moving through the space in the wire. It's not necessarily moving through the conductor. The conductor is just creating the instances, or the frequency at which the power moves in the wire, and all that space in between is kind of its oscillation going back and forth.
Well, one of the things that gets me is, okay, and this is a very bad analogy, but consider a battery to be a bucket, okay? And as you're pouring water out of a bucket, what's to say you can't pour water into the bucket as is being poured out?
It would no longer be DC. It would have to be AC in order.
I don't care. I don't care if it's AC or DC. I just want it to work.
Yeah, well, that's an elusive question. We all face, is that idea. Here's my take on it: is if your system isn't closed, then that is entirely possible. But if you close your system, you only have a certain amount, right? So only a certain amount is usable, because you've created capacitance, right, in that certain amount, or however you want to look at it. Joules, you have joules of energy that can be used in force, and so if you make the joules of energy be abundantly rich, or on a massive scale, then I think that's entirely possible. You just got to cut a hole on the other end of the bucket at a different angle to where the water comes in, but then you're basically just making it pass through, right? There is no bucket. Is the answer to that. Right? There is no bucket.
And that's fine by me. That is fine by me. I don't need a bucket, damn it. But it's just one of those esoteric, what we're dealing with happens on a quantum level at frequencies beyond our control, really. and I think what we're reaching towards really pushes some of the boundaries, especially, of our knowledge, because we're all limited. I'm a moron, I'll admit that. And I'm really Actually, I'm reaching towards a high voltage source right now. And I don't know if you can hear the buzz, but that's my relay I've got going. Self-looped here, through a cap into the battery, from the battery. Well, voltmeter's not on. That was sitting at 12.53 about half an hour ago. And if I turn it on right now, it shows I'm putting up to 1,300 volts through my battery. And that's not cool. So I just disconnected it. And it's been half an hour. I'm checking the resting voltage of my battery. It started out at 12.53, and I don't know if you can see that, but it's bouncing up to 12.5455. Can you guys see that?
Yeah.
Okay, 12.54. Bouncing up to 12.55. Half an hour ago, that was 12.52 to 12.53. And it's been running a relay making an annoying sound for the last half hour.
Yeah.
But the standing voltage in the battery appears to have risen. And the relay is at room temperature. It's not hot whatsoever. The cap is not hot. And this is a 200 volt cap at 440 UF.
How do you have the circuit set up?
That's tricky. I I had to experiment. So it's a 5-point relay. My negative looks like it goes into the negative. Positive is looped back to one of the outputs from the relay. The fifth tap, oh, sorry, I would say the negative of the output of the relay is put into the positive of the cap. Negative of the cap goes back to positive of the battery. And the center tap, which would be the normally closed position, is also looped back to the positive. And the positive is hooked up to the multimeter. And, well, the positive of, let me look, that's hard to trace. No, the center tap of the relay is hooked into the positive of the battery, which is also in the meter, and then the other side of the meter is simply on the negative of the battery. And it has risen in voltage. I'm still looking at it. It's 12.54, up from 12.52 half an hour ago.
And so you're
it's been. Oh, go ahead.
you're shorting the relay? You're just shorting the battery across the relay?
No, I'm self-looping the relay.
Oh, I see.
Yeah, self-looping the relay and trying to gather the back EMF, which is in the thousands of volts. 1,300, 1,600. I've seen, my meter can't handle it, really. But that is what's being shown across my battery, is 1,300 volts. Across a 12-volt battery. And nothing is heating up, period. I had it running for half an hour and nothing is warm.
And how are you stepping up the battery? Just off of this?
The back EMF from the relay.
Wow. So it's not a solid state relay, but it's a solid
relay. Yeah, it's a solenoid in there.
Yeah, that's right.
With the sure. But as that coil collapses off the main in the relay, what would be the primary, as it collapses, you get a huge back EMF spike, and I'm directing that into the battery, back into the run battery.
Right.
I'm sure I need a diode in there somewhere, but I haven't done it yet. I just wanted to see that I only got this running an hour ago.
Hmm.
Would
And
that
I
work
just
with a
wanted.
reed switch?
Oh, what's that?
Would it work with a reed switch and an air core
Well,
coil?
I think it probably would if the reed switch could handle the speeds. Um,
What
I
about a Hall effects transistor?
well, what's happening is that it's a solenoid, so there's a chunk of iron in there wrapped with a wire, creating a decent magnetic field. And when that shuts off, you get the big back EMF spike. Um, with an air core, I wouldn't expect that spike to be as high.
As high.
Yeah, I wouldn't expect it to be as high. I don't know because the SEC works. That's a high voltage AC pulse that comes out of that, and so the collapsing field does create, regardless, it creates a high voltage potential. All I'm doing is driving that back into the one battery. But I tried last night to run this off of my Slayer, and it seemed to hold voltage, but it didn't over voltage my meter the way this is. So I don't know.
hmm. So
Mysteries.
do some. I would suggest doing some longer term tests and see what your standing voltage drops to if it drops. It's supposed to drop, right? And then
Yeah, that's why I was doing this. I just ran it for half an hour to check that out.
right.
And I kept expecting to I kept expecting to hearing a bang, but nothing blew up.
Of the cap,
So,
the capacitor.
yeah, the cap's fine. Cap's cold. Nothing burned out. The first time I hooked it up, it was backwards, and things definitely started to heat up and burn. But I switched it around, and it goes. It goes. It doesn't get hot. And when I did try this, here's the thing. When I did try this with the Slayer, I found that I had worked up a fast switching diode rectifier, and off the AC side, I hung two 9-inch fluorescents. Okay, and then off the DC side, I ran that straight into the battery, and the fluorescence lit up. The voltage did seem to drop slightly on the battery, but the transistor stayed cold. And here's the other thing. I had the transistor grounded from its heatsink, that most of the tip 42Cs or whatever come with. I had that grounded, and the transistor stayed cold, and it seemed to maintain a light output without substantially dropping the battery voltage. And this was overnight. But I wasn't seeing the voltage spikes, so I thought maybe I was on a strange path. I don't know. It was an experiment.
Could be you're using a lot of that potential in the fluorescent lights too. So it's kind of, taking the spikes and utilizing them, so they don't go back and hit the battery.
And here's the thing: the voltage across the battery needed the fluorescent load to maintain itself. If I took the fluorescent load off, the battery voltage immediately dropped. But if I put the fluorescent load on, it seemed to maintain.
Now, did you have your fluorescents hooked up to a ground on the other side, or were they looped together?
Nope.
Just
nope.
off one side of each of the AC side.
Right.
Rectifier.
Yeah, and so that the fluorescent bulbs were just pickup antennas.
Yeah, just picking up. That's an interesting experiment. That's cool. I'm still trying to wrap my head around the relay one you're doing right now, though.
That's
The
really
relay closes and opens itself because it has a normally open and a normally closed set of contacts, and it keeps switching between them.
yes, yes. And I'm trying to use both of them. That's why I think I need a diode somewhere. But it does it. You know, I
Perhaps not a diode, but a resistor.
huh. Well, I'm looking to push all of this voltage back into the run battery.
All of the collapsing voltage back in.
Yeah. So that hopefully I can put a small load on it. I tried it with a 12-volt automotive, like a turn signal bulb, and the voltage did seem to drop. But if I put a smaller, like a 3 or 4 watt 12-volt load across it, I could still maintain a light output while charging the run battery. I'm not sure. I don't have that load available right now. Maybe a small DC motor. I don't know.
DC motor or man, it's interesting.
Yeah. Yeah, never know till you try, man.
Exactly. You could use a resistor as a load too. So
True.
all
But you know, the last time I tried to measure across a resistor with an SEC setup, I came out with outrageous numbers that made no sense.
yeah, no.
And you know, I'm decent with math. It just made no it made no sense, and I could never get the same number twice. There's just a limitation in our meters, really.
Yeah, there's some truth to that, unless you get a really nice meter
Or an oscilloscope.
or
Uh-huh.
something with true RMS. So
Right.
it actually measures the frequencies of the deliverance of joules or current.
Right, right. And I just don't have that. But to me, you know, the numbers don't, I mean, the numbers count for sure, but it's more performance because I live off grid. You know, performance is what counts, period. You know, I don't care what the numbers are. The numbers could read 0 across the board, but if my lights still run, I'm good.
It makes me. I'm curious. I'd like to see how far that goes and keep checking her out.
I'm gonna, I'm gonna, I'm gonna run it for hours at some point. Probably today, you know, because I got other things to do. But
So your losses are
yeah, I'm
sound, and then you'll have mechanical failure after a while on your contacts, right? But for the most part, your losses are just
right.
sound. Huh.
Yeah, you got noise. You have abrasive losses in the contacts. You should have heat losses, but like I said, the relay remains cold, or at least room temperature. And that's strange in itself. You would expect the coil to start heating, the contacts to start heating, but I haven't felt that. So I am going to do some longer, like 2-3 hour runs later this afternoon, and see what happens. You know, it's so simple, it's scary.
Yeah, I know. That's why.
But I don't know that it works.
If you get a chance, you should draw a little schematic so we can all throw it together real quick because it seems so simple just to use a relay.
Yeah, well, I just figured it out, like I said, an hour and a half ago or whatever. So, and I got this idea from Imhotep, who had a relay Bedini charger, and this guy who actually binged it was weird. I had a random search that I came up with that Binge had commented on a couple of months ago, and the guy was running a hydrogen cell and a light, and his voltage wasn't apparently dropping in his run battery.
Hmm.
Very, very interesting. You know, that's a lot of output. And I, I, I haven't written him a message, but he never responded to anyone's questions, as far as I know. Let me do a quick search, and I'll come back with the video that turned me onto this.
Uh, Jeremy says that his wife says to tell Jesus she says hi. Probably said that terribly wrong, but Jeremy's wife says hi to you, Jesus of Nazareth. It's true, you do have
Nazareth.
you kind of have this this light behind you. It's almost angelic. He also says it sounds like it could be conditioning or cleaning the battery plates, which is something I was thinking about, the high frequency pulses too, but still it's interesting. I mean, I guess you're not using a whole considerable amount of current. That's why I said it'd be interesting to see the end result after running it for a long time to really see how much it drops, and what you can do with it.
And yeah, I haven't actually measured the current running through that. Oh, here's the guy, Mark Bellinger.
You have a link?
MarcBellanger. Mark Bellinger. It's called Real Radiant Energy. And it was only like 3 months ago he put this out. I'm going to try to throw up a link real quick. Let me see if I can do this. Got that. Let's see where I am. Oh, shit. How do I put a comment? How do I put a comment down?
Top left, there should be a little thing that says chat. Click on that and just throw it in the little chat window. I'm not sure if people can see it there, but I can always do like a share screen. And
yeah, I just threw it up there.
There we go.
Yeah, really interesting. It's like 2 components, and this, I think, this is just his not the one with the hydrogen cell, but just a simple relay switch.
All right, let me see if I can do this. This is fancy pants stuff here.
Right?
Hold on a second. All right, you guys see that? My end.
Let's see if I can catch it. Hydrogen.
All right, here we go.
My name is Mark
Is it showing up?
Design Technologies.
Yep.
What I'd like to show everybody here on YouTube is
Could you guys see the video? I couldn't see the video.
Yeah, well, that's just what got me there, you know.
Yeah.
Holy shit. Sorry, trying to navigate all this crap. Throw the other one up real quick. Wait.
Oh, right, here we go. Maybe I gotta click on this. Not getting any sound from it.
Yeah, but I can see that's the vid.
Mark.
It's just really.
Technologies. Now, what I'd like to show everybody here on YouTube is this is a circuit that I've created that proves that over Unity is possible. And
Bold statement.
you can charge any battery with that. Like this self-oscillating circuit. It is probably the simplest circuit in the whole world. I mean, the only simpler is it's like a light bulb circuit, but it's self-oscillating. It charges batteries, and it also can power a load and charge the battery at the same time. From the battery it's using and gain voltage. Usually when you have a load on it, though, you'll notice that the voltage pretty much stays the same. It will go up a couple of notches and then drop back down and go back up, go back down. That's what radiant energy does. It's like static, cold electricity. Inside a relay, automotive relay, but you pretty much can do this with any size battery, any size relay, just as long as the relay can be energized, well, be energized by the battery. So what happens is the coil inside of the relay shuts down instantaneously and turns back on. When it shuts down as a back electromagnetic field, like an EMF spike, so you have the field collapses upon itself, and then a high voltage spike is introduced into the circuit, which charges the capacitor and also charges the battery at the same time. The capacitor kind of stops the voltage from overloading the battery and popping the battery.
Are you using an AC cap?
I'm using a DC cap, actually. And that could be part of my issue.
This is a 12 volt.
I just grabbed one off the shelf.
Or replacement for power wheels. And what I can show you is this. We're going to take the light bulb. It's an LED, a high intensity LED, 12 volt LED, like one of those Chinese ones. And it's quiets the circuit down a little bit, but you'll watch. This will charge all by itself.
And that voltage is going to climb to over 12.
Get out of it.
But when I take my readings, I'm getting 1,000+ volt spikes with my meter.
Well, one of the big problems with the meter, like we are talking about, is if it's not RMS, you're not seeing its frequency.
Exactly.
It's kind of hard to just do it right there like that.
And that's why runtime is more important to me. What is the usefulness, you know?
Yeah.
Loading up on
so
battery,
how far does he get into it? 6-minute video. How far does he get into it here? Does he show a diagram?
He shows it go up to over 12. It's really not much, but I did put the other video where he does the hydrogen cell. I put that in the comment box, in the chat box. And, hey, Jeremy's back online.
Yeah.
Low power, highly efficient fuel fee. Won't do any work. Yeah, I don't know. That's why we're here, is to check it out. Because the guy on the second video that I put a link to, he shows a hydrogen cell running, and it seems that his run battery, he only has one battery, seems that it really does the job. I don't know.
Does the hydrogen cell act as his other capacitor? Here it is, right?
It's part of a load. He's got a light bulb in series with it.
12 volt.
All right. Here's this one.
Battery. Double.
That coming in okay? You guys seeing it?
Yep.
Wiring. Nothing. And
not now.
this time.
Not now. Okay.
Because it didn't have enough.
Can't maximize it then. That better?
There you go.
So right now we have a high cell that I call my slinky cell, and a very high intensity light. I just want to show you that we're connected to the meter, we're connected to the light in the cell, and no other place is disconnected to any other energy source.
Now, does he have the cell pointed into the hydrogen? Or, I mean, the
back to the other side of the cell.
light pointed into the hydrogen cell?
From the cell.
Yes.
See, that's an important thing to recognize too, because you're having two energies interact there when you do that. In a sense.
And
You see it bubbling?
Yeah. Oh, just froze up. Cells was he talked about too is you putting light into his cells and oscillating the frequency in such a way that it created a beneficial effect, so to speak. So
Right, and he's using a low intensity light that can't be more than like 4 or 5 watts. That's an LED.
yeah, it's a little LED. It's just a super bright LED.
And he does mention that there's his hydrogen cell is set up for 1 amp, 1 amp draw.
Hmm.
But the guy doesn't have a lot of videos.
Yeah. Well, now it's there, so anybody can look at it and investigate a
Yeah.
little more. So just so I know exactly what's going on.
Well, he doesn't put out a schematic. I tried for 2 days until I found the combination.
Nice.
But I
Five-
have a relay ringing, and I guess I can go hook it up now, start a time scheme. But I'm gonna wait until 4 o'clock my time, so I can go take a break, and then leave for an
Well,
hour
also
and
it's-
see what happens.
Like Jeremy was saying too, it's good to give the battery resting time so you can really see what's happening chemically as far as the.
Exactly.
So.
Yeah, get it back to a rest voltage, which I'm gonna check right now. Uh, 1255 is my rest voltage.
It's still up.
And that's after yeah, it's up. Well, it's bouncing up to 1256. And I ran a 12-volt car light off of this for 15 minutes. I'm not running a car, it's just sitting on my floor. So I drained it down to 12.4 something, 12.41, I think. Nothing conclusive. I mean, these were all sporadic, small time tests. I plan on doing something for a couple hours tonight, really pushing the battery, and then seeing what I can get for a bounce back.
Yeah, that's cool. Well, man, it gave me all kinds of ideas that I want to experiment with. I balance it out. You know me with like a lot of us, I think, with our families, man. We got to balance them out.
Yeah. The first thing I thought is, oh, high voltage, what can I do? What can I drive with that besides, putting it back into the battery? Or can I put in something else and then back into the battery?
Yeah.
Yeah, who knows?
Interesting. High voltage is it can be stepped down in many different ways. So.
Yeah, I have a couple of really flinky ideas about antennas off of the poles of the battery, which I plan on playing with tonight after I get another bottle.
Antennas off of what?
Off of the poles of the battery, to see if I can what's the word? Not correlate, commutate, copulate.
Inductively couple.
Oh, there you go. Couple two batteries through the air from pole to pole with antennas, while getting some sort of light output at the very least in between the air. Maybe a couple of pancake coils just off of the positive of one and the negative of another. See if I can get some radiant exchange between two batteries with a exciter on the other side.
That'd be cool.
Yeah, just a thought.
What's interesting, again, about this is something that's kind of baffling about the players and the SEC and everything is that it doesn't matter how long your wire is or anything, that potential still goes through and still lights up things around it like constantly.
Yeah.
There's no antenna limit in a sense.
You ever see that Maker J 101 video where he was running a Slayer Exciter and he just wrapped, I think it was the output of the L3 around his fluorescents, like all the way down a hallway, around the corners, like 50 feet, and they were all lit.
Yeah. See
And
the
then
one wire
just turned 16 or 17. Fucking blows me away.
Thanks for everyone who posted.
Yeah.
Is he what?
Big batteries, so I don't know that. I guess it's the transistors getting hot, or I'm not sure what, but that'd be cool to know. And I remembered. Right now, I'm powering the charger with batteries. So if I wanted to power this from the wall, I could use some sort of fairly robust, say what, 2 amp, 12 volt supply.
2 amps seems like a lot.
Is that a video?
I'm
Put
just
that
gonna
video and
parallel them and then see how much they draw.
because that doesn't sound like Jeremy's voice. Could be
Just
Not
wrong.
quite.
And boom. See, watch. I got 2 watts, and then I'm just slowly turning this pot, and then all of a sudden, boom, I hit. Whoa, that was like 40 watts. So you can really rock this thing. And you don't see, that's the problem with this 110K pot. I can't fine tune it enough to get in there and get what I'm looking for.
Watching some video, it seems like.
Yeah, it sounds like a vid. Maybe Jeremy has his connections crossed.
Yeah.
We're watching his feed.
All right. Well, with 2 hours, a little over 2 hours in, I should probably kill the broadcast just because it's. I don't know if anybody wants to watch a 2-hour video on YouTube.
I do.
Yeah, I'm sure some people just skim through it and just catch little details of it, you know, so get little bits and pieces. But, yeah, no worries, Jeremy. But so I'm gonna cut the broadcast out, and then I think that one of these, like, I'll maybe do a month out or something, and we can really. I think this one's a little more focused, not quite as sporadic as the last one, but I really liked our last one too because we could see that everybody had so many experiments to show. But it'd be cool if we could all. I think it'd be at the tail end of the SEC challenge too, so maybe we could just explain some of whoever's
good.
Explain some of our wireless transmission stuff or whatever. So, but until next time, I guess. Whoever wants to say goodbye now. Bye.
Bye, guys.
But thanks for watching, whoever is watching this, and adios.